All right, year 10s, today we are looking at the quadratic formula, which is this right here. X is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. Now, x we know is usually the solution to our quadratic. The other polynomials we have are a, b, and c. They are obtained if your equation is in the following formula. Ax squared plus bx plus c equals 0. A few things I want you to note. Your equation must be equal to 0 to use the quadratic formula. That is the first thing you must remember. Secondly, if you would have something such as x squared minus 2x plus 5, then your a value is 1, your b value is negative 2, and your c value is positive 5. Okay? So the symbol does carry on, or collect, with the coefficient of the term that you were trying to find. With that out of the way, we're actually going to start by breaking down the quadratic formula and looking at what is called the discriminant. Now, the discriminant is a section of the quadratic formula that allows us to identify how many solutions there will be. So the discriminant, denoted by a triangle, known as delta, is equal to b squared minus 4ac. Now, you will see this in the quadratic formula beneath the square root sign. Now, in the actual quadratic formula as a whole, you'll see it is plus or minus the square root of b squared minus 4ac. That is how we get our two solutions. There is a positive and a negative out of this. Okay? From here, we can see that if b squared minus 4ac is equal to 0, then plus 0 and minus 0 will equal the same answer. You'll only get one solution. If b squared minus 4ac is negative, you can't square root a negative number. Therefore, there will be no solution. And finally, if b squared minus 4ac is a perfect square, like 16, we'll get a rational solution. But if it's not a perfect square, for instance, the square root of 19, then we will not get a rational solution. But we will still get two solutions. I'm going to talk you through that now. So if you have the discriminant is greater than 0. So that means that b squared minus 4ac is a positive number. Then ax squared plus bx plus c equals 0 has two real solutions. If delta is a perfect square number, then the quadratic has two rational solutions. An example of that would be if you had 1 plus or minus the square root of 16 over 2, then plus or minus the square root of 16 is going to become 1 plus or minus 4 over 2. So it'll be 1 plus 4 over 2, 1 minus 4 over 2. Those are your two rational solutions. If, however, it is not a perfect square, and we have 1 plus the square root of, say, 19 over 2, then your two solutions can only be 1 plus the square root of 19 over 2 and 1 minus the square root of 19 over 2. We still have two solutions for x, but they are not rational. The square root of 19, you will know from your thirds knowledge, is not a rational number. So, what we have is that if delta is not a perfect square number, then the quadratic has two irrational solutions. Now, I did quickly overlook a section of the notes. It does say here once the expression b squared minus 4ac is called the discriminant, spelled like this. Now, to resume our cases. So we know that case 1, delta is greater than 0, it's going to have two solutions. Case 2, if delta is equal to 0. Now, we looked at this before. If you have 1 plus or minus the square root of 0 over 2, that is just going to equal to 1 over 2. You will only have one solution for x. So from this, we know that if delta is equal to 0, then we have one rational solution. Finally, case 3, if delta is less than 0. That means that delta is a negative number. We're going to have, for example, x equals 1 plus or minus the square root of negative 3. You cannot, over 2, cannot find an answer to this part of the question. Yeah? There is no square root of negative 3. Therefore, this is unsolvable. And the quadratic equation has 0 solutions. So it saves us the trouble of trying to solve it. If we can identify very quickly through the discriminant how many solutions there are, then we can quickly tell what our final solution may or may not be and whether it is worth solving. Good luck.